All right, so welcome back to Mr. Fugate's Learning Academy, I guess the last day of it, hopefully. Like I said, today we're going to be looking at transformation. This last transformation is called dilation. Yesterday you looked at rotation, okay? Dilation I think is a little more simple than rotations was. Hopefully you guys agree with me. So dilation, if we think of the word dilation, or dilate, we usually think of our eyes, our pupils, okay? Gets big or gets small. That's the type of dilation we're dealing with here, okay? So a transformation, which is similar to a scale drawing, it uses a scale factor to enlarge or reduce a figure proportionally. Scale factor is the ratio of the side lengths of the image to the side lengths of the pre-image. The pre-image and the image are the same shape, but not necessarily the same size. If the scale factor is greater than 1, the image is enlarged. So if I have a scale factor of 2, I've doubled the size. That's what that means. If the scale factor is between 0 and 1, the image is reduced. So if I have a scale factor of 1/2, it's half the size. Okay? If the scale factor is equal to 1, the image is the same size as the pre-image. So, scale factor. We have triangle ABC, triangle A prime, B prime, C prime. I look at my side lengths here. AB is 1 centimeter. A prime, B prime is 2 centimeters. It's double. B to C is 2 centimeters. B prime to C prime is 4 centimeters. So my scale factor, okay, that one's dead. Okay. Grab a new marker. That one was dead, it was gone. So the scale factor is 2 because it's double the side length. Okay? So if we look at dilation on a coordinate plane, all right? A dilation is a transformation that enlarges or reduces a figure by a scale factor relative to a center point. That point is called the center of dilation. So when the center of dilation in the coordinate plane is the origin, each coordinate of the pre-image is multiplied by the scale factor k, find the coordinates of the image. So here we take x, y, multiply both x and y by k to get kx, ky. So here, triangle ABC has vertices A is -2, 1, B is -4, 5, C is 3, 2. We need to graph the image of the figure after a dilation with a scale factor of 2. So we have A prime, B prime, and C prime, okay? So as we're looking at this, all right, if A is -2, 1, and we're dilating it by a scale factor of 2, we take -2 and 1 and multiply it by 2. So -2 times 2 is -4. 1 times 2 gives me 2. B prime would be 2 times -4, 2 times 5. So I end up with -8, 10. Then C prime would be 6, 4. Okay? So I take that, I go ahead and graph it. So I have -4, 2. That's going to give me A prime. B is now at -8, 10. So that's B prime. And C is now at 6, 4. So that is C prime. So as you can see, if we graph this triangle, which we're going to here, okay, we end up with a much, much larger triangle than what we began with, okay? So that is now our triangle that is dilated by a scale factor of 2. Like I said, much, much larger, okay? So that is us dilating it. This is the first one where what we're doing does actually change the shape and the size, okay? Give everybody a second to get that down. Okay. So example 2, we are once again given a pre-image, and we're asked to take what's given to us and graph the image after a dilation with a scale factor of 1/2. So now we're taking each of these x and y values and multiplying it by 1/2. So we have J prime, K prime, and L prime. Okay? Well, 3/8. We take 3 times 1/2, we get 1.5, or 1.5. And then we get 8 times 1/2, and that gives me 4. I then have 10/6, so I have 10 times 1/2, which is 5. 6 times 1/2, which is 3. And then I have L prime, which is 8 times 1/2 gives me 4. 2 times 1/2 gives me 1. So I go ahead, I'll graph my points. So 1/2, 4 will be roughly here for J prime. K prime is at 5, 3, so 5, 3. Yeah. There. Then L prime is at 4, 1, so I have 4, 1. So I go ahead, okay, I've now dilated my triangle by a scale factor of 1/2, okay? As you can tell, much smaller triangle, okay? Give everybody a second to get that down. Hopefully we're feeling pretty good with this. Okay. So, next one, we need to use coordinate notation to describe what's happening here. So once again, as I said earlier, whenever we're dealing with dilation, okay, whenever we're dealing with dilation, we are just doing x, y goes to k times x and k times y, okay? So I need to figure out what k is. So I'm just going to look at 2 of these points. This is A, this is A prime. So I'm going to look at those 2 coordinates, okay? I'm going to figure out what's the scale factor between them. What do I multiply A by to get A prime? Okay, so A is at -2, 4. Okay, A prime is at -1, 2. So if we look at this, -2, 4 becomes -1, 2. If I look at each of those numbers, I look at my x values. -2 goes to -1. -1 is half of -2. 4 goes to 2. 2 is half of 4. So I'm going to take x, y, and it's going to go to 1/2 x, 1/2 y. Okay? So essentially what I'm saying is my scale factor is 1/2. All right? I believe that is our last example for today. So hopefully that makes sense. I hope that you guys are able to understand this one a little bit better than the rotations. I apologize once again that I wasn't in class for the rotations, but I hope that you guys were at least able to grasp it somewhat. Like I said, use that cheat sheet that I'm going to have attached to the announcement on Canvas to help you out. You'll have an assignment over this. Try your best on it. Get it turned in. I'll be back on Monday. Have a fantastic weekend. Have a fantastic day. Make good choices.